Hey, what's going on, guys? Welcome to my annual practical guide to web development. So this is something I've done every year since I believe 2016 or 2017, and people seem to really like it. It's been requested over and over. So we're going to look at all the possible paths for you to take as a web developer, looking at mostly technologies like languages, frameworks, tools, etc. I will say that not too much has changed over the last year in terms of new tech, so you will see a lot of the same stuff, but my commentary on everything is completely fresh. I didn't rewatch last year's or anything like that, so it's all my current perspective. So before we get started, I just want to talk a little bit about what this guide is and what it's meant to be used for. So this is a roadmap for web developers in 2021 that focuses mainly on technologies from front end to back end, as well as some trends and guidance. And the most important thing to keep in mind when watching this video or looking at these slides is that everyone has a different path and different goals. There's no one size fits all, and that's why these guides are so long, because they're full of choices depending on which path you plan to take, which language, and so on. It doesn't choose your path for you. I do let you know some of my personal choices when it comes to technologies, but it's just that. They're my choices, they're my opinions, so take those with a grain of salt. Now, before talking about any specific technologies, you need to figure out what type of web developer you want to be. There's basically three main types, and this is just web development specifically. We're not talking about other types of programming careers or DevOps specific roles or anything like that. So first of all, we have a front-end developer, which is someone that deals with the front-facing website or user interface. We'll talk about all these technologies, but you're going to be working with HTML, CSS, Sass, JavaScript, maybe TypeScript, most likely a front-end framework like React or Vue, working with the document object model, and so on. You'll probably need to know at least some design depending on where you work. Now, a backend developer is someone that works server-side and usually works with databases, creating REST APIs, web services, etc. There's a whole bunch of languages to choose from when you're dealing with the backend. JavaScript is an option with Node.js or Dino, Python, PHP, C#, and many more. You usually have to have some kind of knowledge of setting up and working with servers as well. And then you have a full stack dev, which does both front end and back end and is usually able to create some pretty powerful web applications. Now, depending on what you do and where you work, you may focus more on one side than the other, but a full stack developer generally knows front end and back end technologies. Now, through this guide, you'll see these little logos here, so FE, BE, and FS. When I'm talking about a specific technology, if you see one of these, it means, in my opinion, you should learn that technology at some point. If you see one of these with a white check mark, then that means it's pretty much required of you to learn that to be either a front-end, back-end, or a full-stack developer. So something new that I added this year, just to kind of give you some more guidance. Now, another thing you want to do is have an idea of where you want to take this. Why are you learning to code? Why do you want to be a web developer? Do you want to work for a large corporation or a smaller firm? Do you want to freelance, run your own business, work at a startup? Maybe you want to build your own applications or software as a services so that you can make money that way. Maybe you want to create content, code as a hobby. There's so many different routes that you can take when you're learning to code. So figure out what really drives you, because the decisions you make really depend on that. All right, so I like to start at the absolute beginning in these guides. So we'll start with some essential tools. Obviously, you need a computer and an operating system. You'll see I have Mac OS underlined. That's what I prefer. Remember, these are just my choices. For most web development, you can use any operating system you want. Windows is fine, Linux is fine. I actually use Mac and Windows, and I also use Linux for my servers. So text editors or integrated development environments are used to write and compile code. For most web development, you're not going to need to compile your code like you would, let's say, for writing desktop tools. My suggestion is Visual Studio Code. I can say with a good amount of certainty that VS Code is the most popular in the industry. You also have Sublime Text, which is pretty popular. It's a little more difficult to use in my opinion. Atom, Brackets. Vim is actually used by a lot of developers as well. It's really not for me, but the people that use it seem to absolutely love it. So you also obviously need a web browser, and I would suggest either Chrome or Firefox. I use Chrome myself, but I'm actually thinking of switching to Firefox for a couple reasons, but both have really great front-end dev tools and plugins or extensions to work with. So the terminal or the command line is something you'll need to eventually work with, maybe not right at first. I prefer the default Mac OS or Linux terminal using Z Shell, but you could use a third-party terminal like Hyper or iTerm if you wanted more customization and plugins and things like that. If you're on Windows, you could use PowerShell. There's also a Windows subsystem for Linux. I wouldn't recommend that for beginners, though. What I usually use on Windows is a program called Git Bash, which gives you a Unix-based terminal. You just install it. You can get it from, I believe it's git-scm.com, and it gives you the Git version control system as well as the Git Bash terminal. Now, as far as design software, this is something that isn't required for most web developer positions. However, I would suggest that front-end developers learn the basics of at least one of these just to create quick mock-ups and UI elements, etc. I prefer Adobe XD. You could also use Photoshop, which I used for many, many years. Sketch is pretty popular, but I believe it's only available for Mac. And then Figma is actually a web-based utility that's really powerful as well and pretty popular. So if you plan on freelancing and you're not outsourcing your design stuff, then you're probably going to need to learn one of these to provide things like client mockups. Okay, so we have some of the basic tools down. Now, the first type of coding that you're going to want to learn is HTML and CSS. Now, I do have Backend here as well because I do suggest that even if you plan on just building APIs and working with databases and stuff like that, I still suggest that you learn HTML and CSS. You don't have to be able to create, extraordinary websites or anything like that, but it's something that I think every web developer should know. Also, as we go through these slides, you'll see on the right here any YouTube videos or playlists that I have that have to do with the topic we're talking about, as well as any Udemy courses that I have that are related to the topic. So you'll see that throughout the video. So for HTML, HTML5, obviously you want to learn page structure, semantic tags like header, section, aside. Try not to use divs, where you don't have to. Basic CSS styling, so colors, fonts, spacing with margin and padding, positioning including absolute, relative, fixed, etc. Alignment is really important, and there's a few ways to do it. We used to use floats back in the day, but now we have Flexbox and CSS Grid, which have been a godsend. So at least learn Flexbox, if not both. Transitions and animations are pretty important for front-end developers. A lot of UIs have some kind of animation involved. Responsive design is extremely important. There was once a time where making a website mobile-friendly was kind of an add-on or an extra service. But for the last, 5 or 6 years, it's basically a necessity. Everything you build should look good on all screens. So you want to learn media queries and fluid layouts so that your stuff looks good on all screen sizes. So now that you know HTML and CSS, Sass is something that you may want to learn, especially as a front-end dev. Sass stands for Syntactically Awesome Style Sheets, and it's a CSS preprocessor, and it allows you to use special features in your styling that you can't normally use in CSS. Now, CSS does now have custom properties, which are similar to variables, but you have variables, functions, nesting, and a whole bunch of other features that you can use with Sass. And even if you don't use it yourself, there's a good chance that you'll run into it, and it's easy enough to learn. You can probably pick it up, in a week or so if you already know CSS, maybe even less than that. So it is something that I recommend for both front-end and full-stack developers. So next we have CSS or UI frameworks, and these offer pre-made classes to create elements on the fly, things like menus, lists, alerts, and much more. Now, I would suggest learning one as a front-end developer. So some of the popular ones are Tailwind CSS, which is really hot right now, and it's a bit different than the others. So something like Bootstrap, which has been around for a while, you have the CSS classes that will give you alerts, cards, and many other elements. With Tailwind, you have very low-level utility classes, so you can create your own cards and alerts and stuff. The downside is that your HTML is going to have a ton of CSS classes in it, but the upside is it's very, very customizable, and you don't really have to write any CSS. Tailwind is my suggestion, but I also underlined Bootstrap just because it's really popular. Bootstrap 5 has now been released. I think it's an alpha right now, but there's a very good chance that you'll run into it. And when something is I guess, relatively easy to learn, like Sass or a CSS framework, I usually do suggest learning it, at least the basics, just in case you run into it. Even if you don't plan to use it, even if you're freelancing and you're going to do everything with pure CSS, then I still suggest learning it because you could run into it with a client website, or if you go to a job or whatever it might be. And the truth is, if you know one, you pretty much know them all. It's just a matter of looking at the documentation to find class names. And one very, very important point I want to make is that you want to learn CSS before you jump into these frameworks. Don't go from just knowing pretty much nothing about CSS to diving into a framework. I can't stress that enough. Just like you want to learn JavaScript before jumping into a JavaScript framework. All right, so for front-end developers, I do suggest learning some basic user interface design principles and practices, things like color and contrast, white space, scaling, visual hierarchy, typography. I mean, if you want to work for a company, someone else will probably be doing the design stuff. However, it's important to have an eye for it and know, what amount of margin looks good, what makes it look cramped, is the text readable, and so on. And I just think every developer should have just a basic eye for design. And Gary Simon actually did a really good video on the channel called UI Design for Developers, and he talks about all of this. So I think that is something to look at, as especially as a front-end developer. All right, so up to this point, we're dealing with, visual elements. You should be able to create a static website, not necessarily create designs, but take a mock-up or a design and create a web page from it. Now, you want to get started on JavaScript, which is the language of the browser. And if you've done any kind of programming with any other languages, you'll pick up the basics pretty quick. And the amount of JavaScript that you'll need to learn really depends on what you want to do. If you plan on being a back-end Python developer, then just learn the very basics, just so you have an idea of how things work in the front end. If you're going to do front end or full stack, you're going to want to learn a lot more, especially if you're doing full stack and you choose Node.js as your server-side technology. You're basically going to be working with just JavaScript, so you want to get a really good grasp on it. So the basics like variables, arrays, loops, that's all the first steps to learning any languages. The document object model, or the DOM, is extremely important. The browser treats an HTML page as a structured document, and you can use JavaScript to manipulate things in that document and make it dynamic. For instance, if you want to click a button, you can have an event that will remove some other node in the DOM. You could have a div or any element and manipulate its styling by adding and removing classes and changing the CSS itself without having to reload the page. So the DOM is something that is really important to understand when you're doing front-end web development. Array methods are also something that you'll be using a lot. Methods like for each, which just loops through an array of items, map, which can manipulate an array into some other type of array, filtering items, reduce, and many other array methods are really, really useful, and you're going to want to learn these. So JSON, or JavaScript object notation, is also important. It's a way to store and send data. It's structured similar to a JavaScript object literal. When you're working with third-party data APIs, JSON is what will be used, I would say, like 95% of the time. Not many APIs use XML anymore, as far as I know. You also need to understand HTTP requests and the Fetch API, which is built into the browser. It's basically a way to send a request to either your own backend or some third-party API and get data back or post data. And it's a big improvement from what we used to do, which was XHR, XML HTTP requests, which were much harder to write and deal with. So the Fetch API is something you're definitely going to want to learn in JavaScript. Now, along the way, there's going to be some other tools that you'll probably pick up, and these are some of them. I wouldn't say that these are required, except for version control with Git. That's something that just about every type of developer is going to need to learn. So version control is really important, specifically Git. Just about every company you'll work for will use Git. It's a way to save, track, and version your code, as well as work on code bases with other developers. You'll need a place to store your Git repositories. GitHub is the most popular, but there's others like Bitbucket and GitLab. Package managers are also used to install packages or modules. Different languages have different package managers. NPM is the Node package manager, which is used for JavaScript packages. Yarn is kind of an alternative to NPM. And then when you get into the back end, other languages have package managers as well. For instance, Python has pip, Ruby has gems, Ruby gems. What else? You have PHP has Composer. So almost every language has its own package manager, so you can easily install things. Now, module bundlers like Parcel and Webpack, these allow you to bundle your JavaScript and use separate files as modules. I wouldn't say it's required to master something like Webpack, because if you move on to a front-end framework, most of that stuff is done behind the scenes anyway. So I'd wait on that for now. I wouldn't say you have to dive into Webpack before you get into React or anything like that. I just wanted to put it here because it's something you may run into. Now, browser dev tools are really important. You should know how to use the console, how to read and log errors. The network tab shows the requests and responses that are made to and from any servers. The application tab is used to work with local storage in the browser, something else you'll need to learn with vanilla JavaScript. You also may want to look at some helpful text editor extensions, things like linting to help you find errors, Prettier to format your code. Live Server is a VS Code extension that's really handy when working with static files. Emmet is used in a lot of different text editors for writing fast HTML and CSS, and maybe some kind of snippet extension. There's a lot of things that can really help your whole overall workflow that I would suggest looking into, and these are just some of them. All right, so creating a nice website or a small front-end app is great, but you should also know how to make it live on the web. So there's different routes to take. Static hosting with something like Netlify is really easy to do, and you can actually do a lot with the free tier, so you don't even have to pay for like personal projects. Netlify uses Git, so all you really have to do is set up Git and push to your repository, and then you can have continuous deployment through Netlify. cPanel is another way to go that's been around forever. The good thing about cPanel hosting is that there's a lot included by default, like email hosting, SQL databases if you need them, FTP accounts, etc. I would suggest at least a VPS, which is a virtual private server. If you do go this route and not using shared hosting, you're going to get a lot more permissions to do certain things with a VPS and better performance as well with either a VPS or a dedicated server. But a dedicated server is, could be over $300, $400 a month. I recommend InMotion hosting for this type of hosting with cPanel. There's multiple ways of getting your files onto the server. Git is used with certain platforms. You can also use FTP, which is the file transfer protocol, or secure FTP. There's other ways to deploy through SSH, which is a secure shell. It really depends on what kind of platform you're using and what they offer. And there's many, many other ways to host your applications, especially your full stack applications. I didn't mention those here because that's really beyond the scope of where we're at right now, like using AWS or DigitalOcean. We'll talk about those platforms later. Okay, so along with hosting, you have to learn how to register and set up a domain name, which is pretty easy. I suggest Namecheap. And again, none of these companies are sponsoring me or anything. These are just services that I use myself. They're also great for email hosting. If you use something like Netlify, you can point your domain to Netlify, your main domain, and then set up your email hosting at somewhere like Namecheap. SSL is secure sockets layer so that everything is encrypted through HTTPS. I wouldn't suggest deploying anything that isn't HTTPS these days. Netlify comes with a free SSL, and so do some other services, but if you use some kind of hosting account, like a cPanel account, usually doesn't come with an SSL. So Let's Encrypt is good for free SSL certificates. You have Cloudflare, Namecheap, and many other services as well. So you just want to know how to host a website, connect a domain name, set up an SSL, and now you're basically a foundational front-end developer. So you haven't learned any front-end frameworks or anything like that yet, but I would still say you're a front-end developer, and you can even start to apply for jobs, even though a lot of jobs are going to require you to learn a front-end framework. So you should be able to set up a productive develop environment. You should be able to write HTML, CSS, JavaScript, use Sass and a CSS framework, which are kind of optional, those two. Create good-looking responsive layouts, be able to take some kind of mock-up, maybe a PSD file or something, and recreate it as a web page. Build websites with some kind of dynamic functionality, working with the DOM, maybe some modals or slideshows, things like that. Connect to a third-party API using Fetch. Use Git with GitHub or some other repository manager, and deploy and manage basic front-end websites or web apps. So to me, in my opinion, knowing how to do all of that makes you a foundational front-end developer. All right, so what now? So this really depends on the path you want to take. You could keep sharpening your JavaScript skills and start doing algorithms or more advanced JavaScript, which we'll talk about later. If you want to stick to front end, move to a front end framework like React, or you could start to learn the back end. So we're going to go ahead and go with front end, because this is kind of the most popular path people take, is going from what we've already talked about to then learning something like React. So as a front-end developer, like I said, you'll most likely need to learn some kind of JavaScript framework. These allow you to build what are called single-page web apps or SPAs, and the page loads with pre-built JavaScript from the framework that is then inserted into a single page. Frameworks allow you to have really intricate user interfaces that you technically could create with vanilla JavaScript. However, it would be a lot harder and it would be a lot more time-consuming. Also, working with a framework and a team makes it much easier because you have a lot of standards that every developer is going to follow, rather than this jumbled JavaScript that you created that no one else understands. And it's important to mention that you can use any framework in the front end with any language on the server. So React can be used for the user interface, and then you can have your API or your backend written in Java, Python, C#, whatever it might be. Now, as far as which to choose, this is completely up to you. This is a question that's asked a lot, and there's no single answer. You want to look at what's being used by jobs in your area, and also test drive them all out so you can see what you really click with. React is what I enjoy. I think that it has an intermediate learning curve. It's the most popular in the industry right now. It was created by Facebook. I prefer it over the rest, but Vue is a close second for me. I think Vue.js is a bit easier to learn than React, and Vue also has an amazing community. It's not backed by any large company like React or Angular is. It's just a bunch of really passionate developers. Angular, in my opinion, is the hardest to learn of all. It does use something called TypeScript, which I'll talk about soon. Angular is backed by Google, and it's still used quite a bit in the enterprise business world. And I'm not shitting on Angular or anything. I think it's a great framework. It's a full-fledged framework, where React is more of a library where you can add other packages to make it function like a framework. But Angular is full-featured. But like I said, I think it is a little harder to learn. Svelte became pretty popular over the past, I don't know, year or two. It's not branded as a framework. It's what's called a compiler, but it allows you to write JavaScript in a clean and effective way, just like any other framework. I'd say it has a pretty easy learning curve, but you may run into some barriers for larger applications, and also if you're looking for jobs. So I'd really only use Svelte for small to medium-sized personal projects or freelancing. Now, before we move on, each of these frameworks has its own ecosystem, and part of that ecosystem is state management. Now, I'm not going to go into depth on what state is, but you can basically think of it as just the state of your application, the state that it's in. Is a menu open or closed? Do you have data to display? This is your state, which can be either local to a specific component or element, or it can be global to share across your entire app or user interface. So we have global state managers that can help handle global state, because it can get pretty messy without using something like a state manager. So React has the built-in context API to handle state, which is great for smaller apps or medium-sized apps. However, if you plan on having a lot of different types of data, authentication, whatever it might be, whatever types of data your application holds, you probably want to look into Redux, which is a really popular state manager for React. I prefer it over the context API, but a lot of people, they don't want to add something if they don't have to. You have others like MobX, but I've honestly never used them. Redux is by far the most popular third-party state manager for React. For Vue, you basically have Vuex. There's some others as well, but I'm not too familiar with them. So Vuex works really, really well for state management. Angular is a bit different. Like I said before, it's a larger framework. It's more full-featured. It has built-in services that you can use to spread state or spread data across your components. However, there are also third-party state managers like NGRX. And then for Svelte has a built-in context API as well. I'm not really too sure on third-party state managers for Svelte. All right, so another language that you may have heard about is TypeScript, and this is completely optional and not something you really have to learn right away, but it is pretty popular in the industry. So JavaScript is dynamically typed, which means that we don't have to define, our variables and our functions as strings or numbers or booleans and so on. However, using a typed language has a lot of benefits, and TypeScript is what's called the superset of JavaScript, meaning it has everything that JavaScript has. It basically is JavaScript, but it has some additional features such as static types. For me, I do mostly smaller to medium-sized projects, mostly for teaching, so I personally don't really use TypeScript that much. I have used it on a large production project, and I can definitely see the benefits. It helps you find errors before they occur. It makes your code more robust. On the other hand, it is something else to learn, and it is more code to type. So it's really preference. Some people love it, some people hate it. It seems to me that once someone starts using it, it's kind of annoying, but then they find themselves not being able to write JavaScript without it, and they love it. So, you can take it or leave it. It is really popular, and it is something that you might want to look into learning. And I also want to mention that TypeScript can be used with a front-end framework such as React. It can also be used on the back end if you're using Node.js. I believe it's even included with Dino, which is a newer JavaScript server-side technology, which we'll talk a little bit about later. All right, so another thing that you might want to learn is testing. And again, this is front-end and back-end. Now, I'll be the first to admit that I slack in the testing department. I think that it should be learned. However, a lot of developers skip it until they absolutely need it. It can feel kind of like a waste of time when you start learning testing, but ultimately it's going to save you time once you know how to utilize it. There's different types of testing. There's unit tests, which will test individual units like functions or classes. Integration tests will test modules as a group, so multiple functions, etc. And then end-to-end testing for your entire workflow from start to finish. I know these are pretty vague descriptions of these types of tests, but the point of this isn't to teach you this stuff. It's just to let you know what it is, and you can decide what you want to learn from it. And testing is done in just about every language, so it's not just a JavaScript thing. All right, so the rest of the slides in the front-end development section are basically just trending and becoming more popular. However, I wouldn't focus on these until you get up to the point where you're comfortable with a front-end framework. And the big reason for that is a lot of this stuff that we're going to look at, they're part of specific framework ecosystems. So first we have server-side rendering, where you build a normal React or Vue app. It's a single-page application, right? It runs on the client. Your browser loads a JavaScript bundle, and everything happens in the browser. However, it's possible to use React, Vue, Angular, or even Svelte on the server side by using one of these SSR frameworks, these server-side rendering frameworks. Now, there's some advantages to using these. One of the biggest is SEO. When you build a single-page application with, let's say, Create React App, by default, if you go and you look at the source code in your browser, you're not going to see much. You're going to see the JavaScript files that load your application. This isn't good for SEO because web crawlers can't see your content. Now, there's other ways around this. But using an SSR framework does it by default. It also makes routing easier because you simply name a file, you put it in a specific directory, and it loads that file in the browser when you go to that URL. And it can also boost performance. As far as which one you choose, it's most likely based on your framework of choice. So for React, you have Next.js. For Vue, you have Nuxt.js, which is basically Next for Vue. Angular Universal for Angular, and then Sapper for Svelte, which I've actually never used. Again, you want to learn the framework first and kind of master that, and then look into things like server-side rendering. Now, another really popular trend right now is static site generators, which have actually been around for a while, but they've become much more powerful in the past couple years. Instead of generating your site pages in real time, they're generated at build time, meaning that there's no generation of HTML or calls to a database. It just responds with the file itself. This makes your website very fast and easy to host. You can actually host your site on a CDN, which is a content delivery network, where your files can be replicated around the world, and it's really, really fast. Now, when we say static site, it doesn't necessarily mean that you can't have dynamic functionality or work with data. For instance, Gatsby, which is React-based, can use React components, and you can have just as a dynamic of a user interface as if you just used React on its own. It also includes GraphQL, which we'll talk about later, and you can use multiple content sources for, let's say, a blog. You could use simple markdown files, or you could even use something called a Headless CMS, which I'll also look at in the next slide, for your data. So if you're familiar with React, I'd suggest Gatsby. Gridsome is Vue.js based. Eleventy is something I haven't worked with yet, but looks really cool. We're actually going to have a guest on the channel soon. He's going to build a small business website with it. Jekyll and Hugo have been around for a long time. Jekyll is Ruby based, and Hugo is Golang based. However, you don't need to know these languages to use the site generators. And you have other languages like PHP has static site generators. There's a whole bunch of other ones as well. All right, so I'm sure most of you know what WordPress is or Drupal. They're content management systems where either you or your client can log in to an area and create content for the website without touching any code. So WordPress and Drupal, they include interfaces for a front-facing website, and they also include the part where you log into you can call the backend and add your data. Now, a headless CMS works in a similar way, but it doesn't have that front-facing web page. It's used strictly for the data part, and you can add whatever you want for the front end. A popular option is to use something like Gatsby, which we just talked about, a static site generator, and then connect to a headless CMS to get your content. So you could have a blog or, a recipe index or whatever it might be. Now, there's a bunch of options. I personally like Strappy. It's an open source Node.js headless CMS that you host yourself. You don't have to sign up for any subscription or anything like that. It's completely free and it's really easy to use. You also have headless CMSs that are hosted elsewhere and have premium packages. If you go over a certain quota, you're charged, but most are really generous and you can get by with like a personal blog absolutely free. Sanity.io is great. There's a crash course on the channel. Also a React Sanity portfolio project on the channel. Contentful and Prismic are two that are pretty popular that I've never used personally. And then WordPress can also be used as a headless CMS because it has a REST API built into it. So you can actually have WordPress as your CMS, but you could use Gatsby, or you could use just plain old React on the front end along with it. Now, the last few slides, the last few technologies that we've talked about can fit into what's called the Jamstack. Okay, it's a web architecture with high performance, security, and scalability at low cost, and it stands for JavaScript, APIs, and markup, which aren't new concepts, but what is new is the way that we use them. And James Quick actually did a really good video on the channel called What is the Jamstack, and he goes into depth on this. But unlike, say, the MERN stack, which is MongoDB, Express, React, and Node, the Jamstack has a plethora of technologies to choose from, including static site generators and headless content management systems. Serverless is another big trend, which basically means that you don't have to manage your own server. Your cloud provider runs a server and allocates machine resources on demand. Hosting services like Netlify offer serverless architectures, like AWS and many others. And you can create specific functions to run specific server-based tasks on demand. James also has a video called What is Serverless on the channel if you're interested in learning more about that. All right, so up to this point, you're definitely not expected to know everything that I just went over. It's simply the options that you have. Some things you should know in order to be a front-end superstar is how to build websites, web apps and interfaces with a front-end framework, work with components and global state, connect to a backend or third-party API using endpoints, and if possible, learn some testing. And then there's some optional things to think about like TypeScript, Jamstack technologies, static site generators, serverless functions, all that stuff, which are, I would say, optional to be a front-end developer. But they are really, really cool technologies that definitely deserve a look. Okay, so now we're moving on to the back end. Now, if you want to be either a back-end developer or a full-stack developer working in the back and the front end, which I'm guessing a lot of you are, you'll need to learn a server-side language. Now, if you already know a good amount of JavaScript, Node.js is a great option. That's what I prefer and specialize in. I like to use the same language on the back end and the front end, but that's just me. I'm not saying that's the best option whatsoever. It really depends on what clicks with you and what kind of work you want to do. Dino is also JavaScript based. It's very, very new. It has a ton of great features. A lot of people say that it might replace Node at some point, but it's still very new, so I would give it some time before making it your go-to server-side technology. Just dabble in it for now. It's my suggestion, at least. Python is, of course, very popular in the AI machine learning world, automation. It's also really popular in web development. It has some really great frameworks, which I'll talk about in a minute. But Python is a great language to learn just in general for many things. So you have C#, .NET, also an available option for the back end. I know a little bit of C#, and I'd like to learn more. It's very clean and structured. I see a lot of larger companies using C#, at least around where I am. Golang is another language that was created by Google. It's similar to C, but with things like garbage collection and memory safety. So it's easier to learn than a language like C. It's also extremely powerful. It's often used for programming across large-scale servers. It's used a lot in the big business enterprise world. So Ruby is another language, and when it comes to web development, you'll probably be using Ruby on Rails, which is a framework if you do choose Ruby. I personally love Ruby on Rails. It's great for rapid development, and it includes a ton of integrated tools. You may hear people say that Ruby's dead. However, I don't suggest really listening to people on the internet, even myself. I mean, take what I say with a grain of salt, but do your own research, look at multiple resources, look at jobs in your area. Ruby definitely isn't as relevant as it once was, but there are still companies using Ruby and Ruby on Rails. It's an elegant language, and it almost looks like regular English. I actually really enjoyed learning Ruby a few years ago. So PHP is another one that kind of gets a lot of hate on the internet. However, I think most people that hate on PHP really haven't used it or haven't used it in a really long time. There's still a huge number of websites running PHP, so it's still relevant. It might not be used at the FANG companies or whatever, but especially if you're doing freelancing for small business websites and web apps, PHP can be a really good option. It also runs WordPress, which is still used a lot, for small business websites and personal websites and so on. And I'll talk about WordPress a little more later on. So Java is probably the most relevant in the big business world. Java was the first language that I ever used. However, I only really learned the basics. There's not too much that I can say about Java for web development. Then we have Kotlin, which is a newer language which easily integrates into existing apps and uses the Java virtual machine, uses the JVM. So Kotlin is being used in a lot of places where Java used to be used, including Android development, but it can also be used in web development. So these are not all, but a lot of the more popular languages you're going to see used in the world of web development. And by no means is this a comparison, or am I saying any of these is better than the other. I don't do those types of videos. I don't, shit on certain languages and frameworks or anything like that. I simply let you know what's available, tell you a little bit about it as far as I know, and it's up to you to decide what you want to do. All right, so I'm not picking any of these for you. Again, I do prefer Node.js, but I also work with Python, PHP, a little bit of Ruby, a little bit of C#. But you really got to look into certain pros and cons in terms of what you're looking to accomplish. All right, so I would say learn a good amount of the language itself. You want to learn all the fundamentals, learn about the ecosystem, the package managers, things like that, and then move on to a specific framework. And most of the time, you're going to be using a framework and not building everything from scratch and reinventing the wheel, especially when it comes to, CRUD-based apps. So for Node.js, Express is definitely the most popular. It's pretty minimalistic. And it allows you to just handle and customize your HTTP request response cycle pretty easily, create middleware, add routing endpoints, and so on. It's definitely my pick, but there's some others as well for Node that are pretty good. Koa is very similar to Express. Nest.js is a larger, more full-featured framework that actually uses TypeScript by default, and it kind of reminds me of Angular, but on the back end. So Angular and Nest might be a good combination. Loopback is another one. You can easily create REST APIs with a GUI tool. Express is definitely the main Node.js framework that's used, and many other frameworks are based off of Express when it comes to Node. So for Python, there's two really, really fantastic frameworks, and that's Django and Flask. So Django is very full-featured and high-level. You get to, you get like a complete admin area built in automatically. There's very specific ways to do things. However, you get a lot of bang for your buck. It's one of my favorite frameworks just in general. And Flask is also really good because it's a nice alternative to Django, where Django is very high level, Flask is low level and minimalistic, but it gives you a lot of freedom. It doesn't have all the bells and whistles of Django, but you get a ton of freedom to do the things you want. And it's actually pretty similar to Express, in my opinion, in terms of how things are done with request and response or whatever, except it's Python, obviously, instead of JavaScript. So PHP has Laravel, which is definitely my choice. When it comes to PHP, it's very elegant, and even people that don't necessarily like PHP still think Laravel is a good framework. You also have Symfony, which Laravel is actually based off of. Symfony reusable components. Symfony, it organizes code in a very clean way. It is a little harder to learn than Laravel, but it's a decent framework. Slim, in my opinion. Slim is another PHP framework that I particularly like for just creating simple REST APIs. Again, it kind of reminds me of Express, but for PHP. So C# has ASP.NET, which is really powerful. Of course, it uses the .NET framework. I don't have much experience with it, but it is a well-respected choice, and it's used a lot in the business world. Java has the Spring MVC framework, which is obviously an MVC, model view controller based framework, like many of these are. Model view controller is a design pattern where the model handles the data, the controller handles the requests and responses, and the view handles the UI or the template. So you want to get familiar with that design pattern, and it can vary across different frameworks. It doesn't always look the exact same. Ruby on Rails, again, full-featured framework for Ruby, also an MVC framework, has a lot of built-in tools and allows you to build things really fast. And then Kotlin, which I personally don't have any experience with, has the Javelin framework and Ktor, which I couldn't tell you anything about. So if you're interested in Kotlin, I suggest doing a lot more research. So a huge part of working on the back end of a web application or creating APIs and services is working with data, and that usually includes working with a database of some kind. And there's many types of databases. The most popular are relational databases or SQL databases, which are use the structured query language SQL, and then NoSQL databases, which also have a subset of database types. For instance, MongoDB is pretty popular, and that's a document database. It's really popular with JavaScript stacks like MERN, MeanStack. It's very JavaScript or JSON-like, and it's very flexible and scalable. Relational databases have been around for, 40 plus years, and they're used everywhere. You have Postgres, which is my relational database of choice. I would use Postgres with just about any language and framework, including Node and Express. I also use it with Python, PHP. MySQL is the one that I used for years, back when I was doing a lot of PHP. Postgres is still really popular, especially in the PHP world. You might also look at Microsoft SQL Server, Oracle. There's a lot of different relational databases out there that have been around forever. So Firebase is a cloud database, and I really wanted to include this in the list because I personally really like it for smaller to medium-sized projects. It's basically an entire platform. It has data and file storage, authentication, pretty easy API to use. A combination of something like React and Firebase may not be great for giant scalable applications, but I think it's a good solution for small personal projects or even small business solutions, freelancing, etc. You also have Elasticsearch, which is a search engine based database, and it provides full text search with an HTTP interface and schema-free JSON documents. It's not something I have a lot of experience with, but I do see it used quite a bit. Object relational mappers or object data mappers are really important. They give you an abstract layer for your application to interact with your database. So a lot of the times you don't have to actually write SQL queries, for instance. You just have this API that you use to interact with your database. Mongoose is really popular with Node.js and MongoDB. Sequelize, also used for Postgres. I believe it can be used with multiple SQL databases. And then SQL Alchemy is an example for Python. You have Doctrine and PHP. Eloquent is what Laravel uses. So there's many of these. So just do your research on what's available for your language/framework. All right, so I was a little confused on where exactly to put GraphQL because it is used by a lot of front-end developers, but ultimately if you're going to create a GraphQL server, it's back-end. It's basically a data query language for APIs. So in many cases, we create and consume data using RESTful APIs, where we send a specific HTTP request to a specific endpoint to get a whole bunch of data. Now, GraphQL is used in a similar way, except instead of having all these different endpoints that return all this different data, even stuff you don't need, GraphQL provides a single endpoint, and you can make queries based on the data that you need, so you don't have to get everything. If it's an API where it has a bunch of user information and all you need is the first and last name, you can make a request or a query to get just the first and last name. The queries that you send to a GraphQL server are formatted similar to JSON, which is the format of the response as well. So your request or your query looks like the response. If you already know JavaScript, you already know JSON, then making queries is really easy to learn. There's a popular client called Apollo that can be used on its own or with a framework like React to communicate with a GraphQL server, which you can implement with Node.js and other languages as well. It's more targeted than a traditional REST API, and it saves you a bunch of trips to the server. And it also works great with real-time applications. So I wouldn't call GraphQL something that is required to learn, but it is pretty popular and I don't see it going anywhere. So once you learn, the fundamental technologies that you need to learn, GraphQL might be something that you want to look into. So real-time applications are really popular. In a lot of cases, you have your client side and you send HTTP requests to the server, where it's an Express server or Django, Laravel, whatever the backend might be, and that's fine, but you have to make a separate request for each task. With real-time apps using WebSockets, in something like socket.io, you have a constant open door of bidirectional communication through events. And there's all types of apps and services that you can build that utilize WebSockets, like instant messaging and chat applications, real-time analytics, document collaboration, binary streaming, and much more. So I think apps with real-time communication are only going to get more popular. All right, so I can actually hear some of you cringing right now, but if you are, it's probably because you haven't done a lot of freelance web development for smaller websites or for people that are on a budget. And WordPress is still used in a decent percentage of websites, and it can still be beneficial to learn. It depends on your goal, though. If your goal is to work at Google or some big corporation, you probably want to pass on WordPress. But if you plan on building websites and small apps for, the mom and pop shop down the street, WordPress can be a good choice. I'm not saying it's the best choice or anything like that, but it can be used. I actually used it quite a bit when I was freelancing, and that was a while ago, but I do still know quite a few people that are freelancing and using WordPress. And I don't just mean knowing how to install it and, install some third-party template with some third-party plugins, but creating your own templates, creating your own plugins, really customizing it with PHP, with JavaScript in the front end. You can also use it as a headless CMS because it does have its own REST API, so you could use React in the front end or Vue or whatever you'd like. But I didn't want to not mention WordPress in this presentation. All right, so as you step up your developer game, you're probably going to learn some DevOps and some other, deployment strategies and learning about hosting platforms. Hosting a full stack app or an API is a bit more difficult than a front-end app or a static website. You need to deal with servers, configuration, file storage, databases, and more. As far as platforms, personally, I like to use Heroku for smaller apps, especially personal projects or projects that I do for courses and tutorials. And then I use DigitalOcean for larger apps that I plan to scale. DigitalOcean is a cloud hosting company, and if it gives you full control over everything down to what operating system you want to install. And this takes a lot more knowledge than using something like Heroku, which is it's basically a platform as a service, and many things are already set up for you. It's just there for you to use. Where DigitalOcean, you get pretty much just an empty computer, an empty operating system, and you install Nginx or whatever you want to use onto it. So AWS is a very popular option for large-scale projects. It's used a lot in the big business world. However, I just think it's overcomplicated and it's overkill for anything that I personally would build. So I don't use AWS all that much. I use S3 buckets from time to time, but that's about it. I definitely don't have a lot of experience using it for hosting. Azure is another big platform that is popular in business, especially in the Microsoft world, but I've actually never used it. Now, you'll need some kind of web server to serve your backend code. Nginx and Apache are really popular. I'd suggest Nginx. It's easier to configure, in my opinion. It works well with Node.js, which is what I specialize in. It works well with PHP. And if you use some kind of platform as a service like Heroku, you probably won't have to do much configuration, though. So it's going to depend on where you're working and what you're doing as to how much of this type of stuff you're going to need to know. So containers are something you may want to get into. If you're going to be doing DevOps, you'll definitely want to learn Docker, which gives you a way to run your applications in a virtualized environment called a container. This is useful for teams, so your application runs in the same environment regardless of which physical machine it's on. Because we all know if you build an application, you run it on different machines, different operating systems, it can behave in different ways. So Docker prevents that from happening. You can install specific pieces of software in a container, such as an Apache server, a Postgres database, basically whatever you want. Kubernetes is often used with Docker, which is a system for automating the management of containers. I don't have much experience in it, but it is extremely popular in the DevOps world. So for image and video hosting, you can use a local method, use your local hosting, or you can choose to upload to something like Cloudinary or Amazon S3. I like Cloudinary. It has all types of media APIs, and you can manipulate images and optimize your media. So continuous integration and continuous deployment is also something you'll need if you go into DevOps. Jenkins and Traversy are pretty popular when it comes to automating and facilitating continuous integration, testing, and deployment. As a web developer, you most likely won't have to, even come close to mastering these technologies. It's more on the DevOps side of things, but it's good just to get your feet wet in some of this stuff. All right, so I know that was a lot to go through, but keep in mind, you don't have to learn everything, even close to everything. It's just options, right? But to be a full stack developer, you should be comfortable with building front-end interfaces as well as server-side programming. You should know a server-side framework, be able to work with and structure databases, understand HTTP, and create RESTful APIs. You should be able to at least do a basic full-stack app deployment to some kind of platform or service. You should also be very comfortable with the terminal as far as navigating your system, using Git, working with certain CLIs, network commands, and so on. All right, so now we're going to move a little past basic what you would think of web development, but still using the same type of technologies. So learning mobile app development can be very beneficial, whether you do it for a company or for yourself or your clients. Flutter is an open source user interface software development kit, or SDK, and actually uses a language called Dart, which, if you know JavaScript, is pretty easy to pick up. Flutter is extremely powerful, and it allows you to build native mobile applications. This is what I prefer out of the list. However, if you already know React, you may want to get into React Native, which is a framework for building native mobile apps with React. You also have Ionic, which is JavaScript-based. Xamarin allows you to build mobile apps with C#. All of these technologies allow you to build cross-platform apps, so both Android and iOS. And then you, of course, have Kotlin if you want to build native Android apps, and Swift for native iOS apps. Now, you also have the option to build progressive web apps, which are regular web applications built with HTML, CSS, and JavaScript, but run and feel like a native mobile app, and not just a responsive website, but really feel native. And there's a few things that your app needs to be considered a PWA. It needs to be built for all screen sizes, big and small. It should serve offline content if there's no connection, and this can be done through the use of service workers in the browser. So you definitely want to look into service workers if you're looking to learn progressive web apps. It needs to be HTTPS. It should have a native experience and feel. You can even make them installable with splash screens, etc. Progressive web apps are definitely something that we're going to see a lot of in the future. Now, we also have the ability to create desktop applications with web technologies. I'd say Electron is the most popular. You can use JavaScript to create desktop apps. In fact, many of the really popular desktop apps today are based on Electron, such as VS Code, Atom, which is another text editor, Slack, Postman, and many others. In fact, a lot of the desktop apps that I use are Electron based. NWJS is an alternative to Electron, which it's also JavaScript. Then you have technologies like Python, tkinter, if you want to build desktop apps with Python. Then, of course, you have native languages like C, C++, Java, C# can be used to build desktop apps, but that's going on beyond the scope of a web developer. All right, so artificial intelligence and machine learning are also a bit beyond the scope of web development. However, there are certain situations where it can be beneficial to learn. It's only going to get bigger. It's only going to get bigger from here. So if you want to create or integrate automation and tools that use AI, there's machine learning APIs you can work with. It's used to understand user behavior of web apps, engagement, analytics. There's also AI tools that can be used to actually write code. Just check out GPT-3. I know this scares a lot of developers. However, I think of it as a tool that we can use in the future. I don't think that AI is going to completely replace human developers, at least for a very long time. All right, so the last technology that I want to mention, specific technology, is WebAssembly, or WASM. And WASM is an efficient low-level bytecode for the web. It's an improvement to JavaScript, meaning it can do much more powerful things in specific areas. However, it's definitely not a replacement for JavaScript. It's used for things like video games, video and image editing in the browser, things that JavaScript doesn't do all that well. So it actually works alongside JavaScript. You can use languages like Rust and C++ to work with and then compile to WebAssembly. For JavaScript developers, there's AssemblyScript, which is actually a variant of TypeScript and makes it easy to compile WASM without having to learn something like Rust or C++ or some low-level language. So definitely something that we're going to see more of in the future as the web becomes more powerful. So before we wrap up, I just want to mention a few things that all web developers or all programmers in general should look into at some point, not just for practical reasons, but to just to sharpen your skills and make you a better developer. Now, no matter what language you specialize in, algorithms can really help your logic, your critical thinking skills, your ability to solve problems. They're not practical in a sense where you're going to run into fizzbuzz or palindromes in your daily activities at work, but I think of it as like a football player lifting weights. A football player doesn't lift weights on the field. However, it really helps them become stronger overall and a better player overall. And there's websites like Code Wars, HackerRank, and many others to practice algorithms and challenges. So it's definitely something I'd suggest for whether you're front end, back end, full stack, whatever. So data structures are also important regardless of language. There's ways to organize and manage data effectively so that you can perform specific operations efficiently. There's data structures that are primitive to the language that you're using, which I would say is something that you need to understand. And then you have other types of data structures that are non-primitive that you can create as a programmer. For instance, linked lists, stacks, queues. Being able to create data structures it's also really good practice, again, regardless of language. Now, as you become a more advanced developer and write more intricate code, you might want to look into specific software design patterns, which are general reusable solutions to commonly occurring problems. And design patterns are language agnostic, just like algorithms and data structures. Some examples are the singleton, facade, bridge, strategy, and observer pattern. And these are actually described in Jack Harrington's video on the channel if you want to look more into these. All right, so we just went through a crap load of information, pretty much over an hour's worth of technology. So I know it can be really overwhelming, but just know that you're only going to have to learn a fraction of what we've talked about. My goal for this is just to put everything on the table and for you to pick up what you want. And that really depends on your path. If you're a front end developer or want to be a front end developer in, let's say, the Miami, Florida area, look at specific job listings and see what they're looking for, and then go through this video or these slides and pick out the fundamentals and the necessary technologies for that path. If you're going to freelance, you might have a different path. If you're going to build your own applications and try to sell them or license them out, you might have a different path. But just be sure to have a plan. And I know plans change. I've went from freelancing to working for a company, back to freelancing and starting my own business, hiring people, and then ultimately ended up doing content creation. So your path might change in a big way at some point, but at least have that initial plan. Now, as far as learning methods, everyone's different. Everyone learns in different ways. I prefer watching tutorials and courses, but some people might want to read books, written tutorials, or even something like podcasts. Just be sure to create your own projects in addition to anything that you create from course content or learning material. You want to have a portfolio of your most impressive projects, and this is going to help you find a job or get clients if that's, if you're doing the freelance thing. If you're self-taught like I am, this is even more important because that's really how you can show what you're capable of. And I think a good portfolio is important whether you're going to get a job at a company or you're looking for clients, because you need to prove yourself, especially if you're self-taught as I am and you don't have a degree. So I think a portfolio is really important. Also, networking is really important. Online, create social media accounts that are specifically for professional reasons. LinkedIn, really important. Twitter has a fantastic developer community, and even creating YouTube tutorials if you can. I'm not saying go into content creation as a living, but it's something else you can show so that you have so you can prove that you have a passion for what you're doing and you actually know what you're doing. Once you have a decent portfolio, you can start applying for jobs or looking for clients, whatever it is that you want to do. All right, so that's it, guys. I know this was a long video with a lot of information. Again, try not to get overwhelmed. You're not meant to learn everything here. I don't even think that's possible. So take your time, start with the necessities, and work your way through your learning path. Thanks for watching. I have videos on the channel for most of the stuff that I've talked about, so be sure to check those out along with my Udemy courses. And I wish you luck on your journey as a web developer, and thanks for watching.